Sir, you call me.
Yes, Mr. Andy. Please give me some information about this case.
Sure. The victim, called Thomas, 30, was a chemistry teacher of Beijing National Day School. And last night, Dr. Thomas' body was found in his laboratory. The cause of his death is unknown.
I see. Today, I, Detective Robert, will definitely get to the bottom of this case.
Again. Here is the crime scene.
What do you think, Mr. Andy?
There was a lot of blood on the victim's clothes, but the clothes were not broken, so the killer must have changed them for him after the murder. The victim's body must have been covered in knife wounds to bleed so much blood. It may be the cause of his death. The poor daughter must have been cruelly abused before he died.
Sorry, Mr. Andy. I'm afraid it's not blood, but the strawberry milkshake I just drank.
Where that strawberry milkshake comes from? And why you just poured it so quickly?
No worried. I've just found out the cause of his death.
What?
It's poisonous. See, there's some solution dropping from his mouth.
Why there's solution dropping from the dad's mouth?
It must be a type of halogen. I've tasted there are 7 valence electrons in this element.
Why you taste it? And how you really taste out there is 7 valence electron in that element?
But I'm not sure what exactly the element is.
Hi! I'm reborn! Do you want to know what the unknown solution is that caused my death? I'm going to use an experiment to explain it to you.
The body sit up! Oh.
The aim of the experiment is to determine the unknown solution based on the observations of the reactions of halide ions with potassium chloride, potassium bromide, and potassium iodide. Halogens are a group in the periodic table consisting of 5 chemicals: fluorine, chlorine, bromine, iodine, and acetone. Since they are in group 17, having 7 valence electrons, they all tend to gain electrons in chemical reactions. This makes them strong oxidizing agents. The silver nitrate solution reacts with halide salts, precipitates with different colors are formed. We can test what halogen ions the unknown solution contains by adding silver nitrate and comparing the color of precipitates formed with the color of silver bromide, silver chloride, silver iodide precipitates. To carry out the experiment, first you need to place potassium chloride, potassium bromide, and potassium iodide into 3 separate test tubes. Then you should add 1 to 2 drops of 0.2 molarity of silver nitrate to each test tube. The above table is the result of observation. As you can see, the tube containing potassium chloride has a precipitate that has a cream color. The one containing potassium bromide shows a pale yellow color, and the one containing potassium iodide has a white color. In the experiment, while adding silver nitrate to the unknown solution, the precipitate formed and has a cream color, which is the same color as silver chloride precipitate. So, the unknown solution may also contain chloride ion.
Okay, that's it! Have you learned about that?
Thank you, Mr. Thomas. Now I know what halogen this unknown solution contained.
Sorry, I think I just had some illusion. I just see the body set up.
Shh! I have known what the unknown solution is. We are so close to the truth.
I'm not feeling good. What's wrong with me?
Haha, you will soon die.
Why?
Because you just tasted the solution in my mouth.
How many time I'm left?
Alright, now let's do an experiment to test how long you can live.
The purpose of the experiment is to examine the reactivity of the halogens, particularly chlorine, bromine, and iodine. You can know that a more reactive halogen will displace a less reactive halogen from its compounds in solution. To start the experiment, you need a goggle, a bench mat, 5 to 10 test tubes, a test tube rack, and 20 test peptides. You also need to prepare for the solutions 0.2 molarity potassium chloride solution, 0.2 molarity potassium bromide solution, and 0.2 molarity potassium iodide solution. Chlorine water, bromine water, and iodide water should be prepared too. After you collect all the materials you need, you can continue your experiment. Firstly, you should add about 1 centimeter cube, about half a peptide full of potassium bromide solution to the test tube. Then, you should add 1 drop of chlorine water and gently shake the test tube to mix the contents. If you see any color change, make a note of it in your table. If you do not see a color change, add up to 9 more drops of chlorine water. If there's now a color change, record it in your table. Based on the above procedures, you have to carry out 5 sets of experiments by adding chlorine water to potassium iodide, bromine water to potassium iodide, bromine water to potassium chloride, iodine water to potassium chloride, and iodine water to potassium bromide. The above table is the result of observation. When chlorine water is added to potassium bromide and potassium iodide, the solution darkens, which indicates that 2 reactions took place. Bromine water only reacted with potassium iodide solution, and iodine didn't react with any of the solution. Thus, you can draw a conclusion that chlorine is more reactive than bromine, and bromine is more reactive than iodine. According to the reactivity trend of the 3 elements, you can deduce the reactivity trend of group 7A. It is apparently that as you move down the group, elements become less reactive. Because when an element in group 7 takes part in a reaction, its atom's outer shells gain an electron and form negatively charged ions called anions. The less easily these anions form, the less reactive the halogen. Going down group 7, the atoms become larger. The force of attraction between the nucleus and the outer shell decreases. An outer electron is gained less easily. The halogen becomes less reactive.
That's it! From the time you asked me, you have 15 minutes left.
So, how much time I left now?
3, 2, 1. Time's up! You're dead! Poor guy.